Good evening, everyone, and welcome to another evening of our November to Remember talk series of 2024. Now, this evening we have Dr. Lu. Thank you for joining us. And my name is Lovely Anna, and I'll just read a brief introduction to our speaker for this evening. So Dr. Lu is a principal research scientist and leads the responsible AI science team at CSIRO CSIROs at Data61. She was the winner of the 2023 APAC Women in AI. It's a Trailblazer Award. Congratulations for that. And Dr. Lu has also contributed to key responsible and safe AI initiatives, such as Australia's AI safety standards and AI safety research network, which I believe is the OECD AI. It's Trustworthy AI Metrics Project, the International Working Group on AI Meteorology, and EU General Purpose AI Code of Practice. Now, her current research interests include responsible and safe AI, AI engineering and software architecture. She has published over 150 papers in premier international journals and conferences. Her recent paper is entitled Towards a Roadmap on Software Engineering for Responsible AI. And this has received the ACM Distinguished Paper Award. Dr. Lu's latest book, Responsible AI, Best Practices for Creating Trustworthy AI Systems, was published by Pearson Addison Wesley in December 2023 and is the world's first responsible AI book for practitioners and became Amazon's #3 book on AI. So congratulations for that also. And just to round up now, her forthcoming book, The Engineering AI Systems Architecture and DevOps Essentials, is set to be published by the same publisher by January 2025. And we'll just hand over to you now for the presentation. Thank you.
Thank you. Thanks for the kind introduction. So let me share my slides. Can you see my screen?
Yes, we can. Thank you.
Okay. Hello, everyone. My name is Qinghua Lu. I'm a researcher from CSIRO Data61. I'm also leading the responsible AI science team in Data61. So before I start, just want to quickly introduce our organization and team. So CSIRO, as introduced, it's Australia's National Science Agency. It was formed back in 1916. Now we have like around 5,000 people based across 50 sites. And Data61 is one of the 9 research units. We focus on data and digital science and technologies. So for responsible AI, we have actually a very young team formed in 2022. But we grow very fast now. We have around 30 full-time researchers and engineers in the team. So regarding the background, we have researchers with like software engineering background, and also we have researchers working on machine learning, statistics, and also human AI interaction, etc. And we have 6 colleagues ranked in the top 30 for responsible AI based on their Google Scholar citations. And here I also put 2 books cover here. So one is Responsible AI. It has been published last December. Mainly talk about what responsible AI is, and also the key best practices for implementing responsible AI for different types of stakeholders in the AI ecosystem. And also we included some case studies in this book. And our new book, Engineering AI Systems, it will be published early next year. And I think it's already available for pre-order on Amazon. For this book, we talk about like what AI engineering is and the key software qualities for AI systems, how to address these quality attributes using architecture and DevOps approach. So that's a brief introduction about our team. And then here, this slide is what responsible AI and AI safety is. So the first definition I put here is from our responsible AI book. So you can see it's a practice of developing and using AI systems. And I think that the purpose of AI, responsible AI, is like to ensure the AI systems provide benefits to humans, while minimizing the risk of negative consequences. So both positive and negative, they cover. And about AI safety, actually last week I attended a AI forum in Australia. We talk about the difference between responsible AI and AI safety. And actually AI safety, the reason it has attracted a lot of attention is last December, I think the first AI safety summit was held in UK. They signed on I think Bletchley Declaration.
Dr. Lu,
So
Dr. Lu, sorry for cutting you off. I don't know, the slide is not showing well. I don't know whether it's from my side or everybody's getting the same thing.
I can see the slide. It's what is responsible/safe AI? Is that the slide?
yes, that's a slide.
Oh, I don't know. I'm seeing different thing. Okay, just wanted to be sure. I can see
Maybe
it.
it takes time for loading the slide.
Yeah. Okay.
Let me move back and
Yeah.
it is shown.
Okay. No, if everybody's saying the right one, then it's okay. But I don't know what I'm saying. Okay.
Okay, yeah. Yeah, so I think the key difference is maybe responsible AI is a more broader concept, and AI safety like a part of responsible AI. In some cases, I think they are interchangeable these days. Like AI safety used to be more about like just no harm to humans, but I think now it's more like talking about the severity of the AI risk, not, rather than just specific risk of AI systems. And I think in terms of methods, maybe responsible AI is also broader, like talking about risk assessment, mitigation, and usually I think organizations use this responsible AI these days, like talking about a top-down risk approach for implementing responsible AI. But like AI safety is more for more around technical methods, like talking about evaluation methods, benchmarking testing, and I think still there's a gap here. We need to think about how to connect the technical methods with governance for AI safety. Like if you have collected your evaluation results, what does it mean for AI risk? So that's my own understanding about responsible AI and AI safety. But I think for most of the slides here, they are interchangeable. And I have seen, as this slide show, I put like EU AI Act, NIST standards, ISO standard, and for AI safety, Benjo last year, he published a scientific report on AI safety, and in Australia, we have released a deployer version of AI safety standard, and now we are working on a new version for developers for achieving or ensuring AI safety. But I think the main argument here is like those ethics principles or AI safety standards, they are very high level for practitioners to use and a bit abstract. I think we try to make them more actionable or operationalized. And also, if you look at the academic papers, most of them are still talking about model. Even these days for AI safety, I think they talk about large language model safety issues, how to do testing, model evaluation, or red teaming. But our focus is more on system level. We try to fill the gap between high-level principles and the model-level solutions. And that's why in the middle you can see our approach. We call it responsible AI engineering, but sometimes these days I call it responsible / AI engineering or safe AI engineering or safe / responsible AI engineering. And the idea of this approach is we want to have like 3 perspectives. The first one is like a governance perspective, including industry level, organization level, and team level. Then from development process perspective, I think we need to work on tools or best practices for different stages of the software engineering lifecycle. For system perspective, we think architecture and also system level techniques are quite important. And also on the right side, you can see we put trust and trustworthiness because we feel these two are 2 different things. Even a very trustworthy system, maybe people still do not trust the system. So, and here, as I mentioned, I think it's very important to connect the high governance level with engineering level, including development process and product design. Because you have seen many efforts have been put on governance, but we need to link them to the engineering practice. Then we can track how well the team has done in order to support the policy level or the governance level. And our first work on responsible AI is actually a question bank. So we collected, I remember, around 30 frameworks for AI risk assessment from the industries. And based on those frameworks, we extracted 300 questions for doing AI risk assessment. So here I put some screenshots just trying to show the structure of the question bank. If you look at the top left, you can see for each of the AI principle, we have like a principle level questions. Then we have categories, subcategories. Subcategory, we have a set of sub questions. Then for the question, we identify the ID, the level of the question. So you know it's like principle level question or category level question or subcategory level question. The stage means this question is for example, project planning or for system design or for testing stage. Then the source means this question was extracted from this standard or EU AI Act or other standard. So it's like a mapping for this question. And we also have, I think we missed a stakeholder. We have done the mapping to stakeholder, like which stakeholder should ask this question and which stakeholder should answer this question. So we think they are very important for the AI risk assessment process. And on the right side, you can see the card as an example for transparency and explainability. For example, the principal level question could be, do you disclose information about AI systems, including related risks and opportunities, and inform stakeholders about the use of AI? Then we have some sub-questions showing the level, stage, and source. And once we have the questions, we need to answer the question. So we believe the technical tools and also metrics will be helpful for having the metrics. We can think about like maybe we can use them to concretely measure the AI risk. And here we follow the idea from also software engineering metrics. We classify the metrics into process metrics, resource metrics, and the product metrics. So the process is like, is there a process in the organization? Is there a risk committee, for example, in the organization? Then resource metrics could be like tool metrics, whether they use any tools in this process. And the product metrics is the output from the process, like some reporting document or some diagram or testing results could be the product metrics. And on the right side is a paper we publish about accountability metrics. Then once we have done the risk assessment part on the left side, so we can use like a risk register template. You can customize your organization's own risk register template, and you collect the answers by using the questions. Then we need to do the risk mitigation. So here we use pattern-oriented risk mitigation approach. So pattern is also not a new concept. It's from software design community or software engineering community. It's like a reusable solution to a recurrent problem in a given context. I think for software architecture, we used to talk about design pattern. So how to design the architecture using reusable design solutions. Here we call them product patterns. But in our pattern catalog, we also summarize a set of process best practices and the governance mechanisms. We call them all patterns. I think the advantage is we want to reuse the template to describe the pattern. So it's the description is more structured or rigorous. It's easier for us to summarize the best practices for responsible AI. And also I think it's easier for our audience to follow the description. So I will give an example later. So this diagram just given like an overview of the pattern catalog. So the triangle on the top is the governance patterns. So you can see it has 3 levels, industry level, like AI, having AI regulation, or building code could be industry level. The organization level, building the leadership commitment or risk committee, having the training programs in the organization could be organization level. Then team level, maybe like integrating or tight coupling of AI development process and non-AI development process, or having stakeholder engagement, have a diverse team, could be team level governance mechanisms or patterns. Then I think the idea here is we try to connect the industry level with organization level and team level. So in order to support industry level, what we can do at organization level, then what we can do at team level. Also, we would like to connect governance with process with product patterns. So the process patterns at the on the left bottom side. So you see it's we classify them into different stages of the development process life cycle. So like for requirements, we can have responsible in a user story, for example, or design level, what kind of patterns we can have to support this stage. Then on the right side is like more about reference architecture for building responsible AI into the AI products. So responsible AI can become a feature of the AI products. One example is if you look at the top layer operation infrastructure layer, one design pattern is called responsible AI black box. So you can record the important input and output information of the AI systems. Then later you can use the data to trace back to identify the reliability, accountability of some AI instance. And of course, there are other patterns here for you to use to design your architecture. But here, just want to use this, I think, to emphasize it's important also to have patterns at from architecture perspective. And there's a pattern at supply chain layer called bill of material registry. So that's a design pattern. And if you look at the process pattern, we also have like bill of material and also risk assessment. And organization level, we have risk assessment. The team level, we have verified claim of AI system artifacts. So these patterns are actually related patterns. So we also want to show here like they are connected. That we can like from the technical team, we can do something like to support responsible AI. Then we can support the upper level governance or development best practices from different angles. And this is one example for the design pattern, for the product pattern called AI mode switcher. I think it's also can be called a circuit breaker. So for this, for each pattern, actually we have one sentence summarizing the pattern at the beginning. Then we introduce the context of the pattern, explaining what kind of problem this pattern can address. We talk about the solution details, also showing benefits, drawbacks, and what kind of existing applications have adopted this pattern. We call them known uses. And we have also done the mapping as mentioned. So we will add a new field called mapping to standards for this template. Actually, you can already access the mapping from our pattern catalog website. So you know which pattern could be adopted to like help or support your compliance process for some standards. And I think last year after release of ChatGPT, we also looking at how to build a chatbot building on like a GPT model. And this is actually the first application we have built using our own knowledge bases. So we try to like build a chatbot for question answering all the questions about AI risk. So the stakeholders, they can come to our web application, they can ask questions about their AI project's risk. So here it's just a screenshot. You can see the stakeholder after answering some configured questions. They can ask, so I came across this news article this morning, and he put a link here and asking our organization is currently developing a chatbot for science. I'm wondering what kind of AI risk I'm facing. Then we try to answer the question using our question bank and the pattern catalog. And in addition to question bank and pattern catalog, we also integrate a knowledge base called AI incident database. We manually label those incidents. I think the purpose of the for using this incidents is we want to map the AI use case mentioned by the stakeholder with historical AI incidents. So then we know what kind of principles are relevant to this AI application. So you see on the right side is a process, how we process the stakeholders query. Then once we have mapped the relevant AI incidents and identify the relevant principle, we will extract all the relevant questions for AI for this principle. Then we ask the questions to the stakeholder. Then based on stakeholders' answers, we like identify or give the score about the AI risk. Then we recommend patterns as risk mitigation solutions for these stakeholders. So that's the idea of this chatbot. And then on the right side, left side, you can see it is now logging as stakeholders. We can also log in as AI experts or responsible AI experts to check the answers. So we can make the we can review the answers before we return the answer actually. But now I think based on the like real-time requirements, usually we can like enable reviewing report only. So before generating the entire report, we request all the AI relevant AI experts to review. So that's the early stage of the work for foundation model systems or large language model systems. And moving, I think from that chatbot, we started working on foundation model-based systems. And one, I think very well-known, or this is very hot type of application is AI agents. And we also summarize the unique characteristics of agents. So first one is complex architecture. And as mentioned at the beginning, AI agent is like an AI system, and AI system is not just the model, it has other components. And same to agents. So agents is not just large language model, it also has out of large language model components like guardrails or external tools, data retrieval components. So we need to think about the entire architecture of AI agents. And those agents, those components, maybe they are from different stakeholders. For example, the agent at runtime, they can decide which tools they want to use to achieve human goals. So those tools may be from external stakeholders. So the architecture is quite complex. And the second one we put here is autonomous operation. As I mentioned, they can decide like what kind of tools agent can call during runtime, and actually the input of agent, they are very different from traditional software. They are not detailed requirements or instructions from the users. Usually the users just give very high level and unspecified goals to the agents. Then the agents, they decide how to achieve the goal, like what's the plan, or which tool to call, which data knowledge base they want to retrieve. So the second characteristic here we put is autonomy. And the third one is a non-deterministic behavior. So even for the same input, the large language model or the agents, they can generate different outputs. So this one may introduce like unintended consequence. And also, I think it is the main concern for one of the main concerns actually is for AI safety solutions. And usually, if you look at the existing papers, the agents, they are expected to be continuous learning, continuous evaluating. So that mainly because the agents in the design, we introduced a component called memory. So the memory can support this continuous evolution feature. So this is also a unique characteristic of agents. So to understand agents, I remember end of last year, there have been already many papers talking about AI agents. And that's why our first work was looking at the reference architecture. As I mentioned, architecture is quite important to understand or to address responsible AI safety issues. So we reviewed the existing agents and also extract the architectural components, architectural structures from those agents. I identify a template for designing agent. So the left side is like an ecosystem architecture. You can see there are two types of agents in this ecosystem. One is a coordinator agent. One is worker agent. So the coordinator agent, you can also call it orchestrator agent. So the users will send the goals to this coordinator agent. Then the coordinator agent will do the reasoning, do the planning, suggest a workflow. And once the workflow is approved by the user, it will connect with different worker agent to complete some specific task specified in the workflow. And the worker agent, they could also leverage external tools or external knowledge bases to complete the task. And on the right side is more detailed design of a single or individual agent. I think we classify the architecture into different layers. The first layer, top layer, is interaction engineering layer. So instead of just waiting for the users to give the instructions or goals, so the agent can also make or suggest goals more proactively based on the context information they detect. For example, based on the previous papers the users have read, based on the document annotations or comments they have made or highlight. And they can also detect through the IoT devices, like some papers talking about eyeballs tracking or actions tracking, gesture tracking, and some papers talk about interactions between humans and the computers. So those type of multimodal information could be used as context for agent to make proactive suggestions. So if the agent they get some next step goals, the users they can approve or reject. Then once approved, the prompt can be sent to the large language model actually. But here the prompt sometimes lacks some context information or some required information. So we can also have like a prompt optimizer component here. I think in this version we call them prompt generator. So you can, for example, specify the agent persona or the guardrails for the agent to give more information, help the large language model to understand your goal or the scope of the agent or the rules of the agent. Then this prompt is sent to the planning layer, so the agent they can figure out the plan for achieving the goal. And if the plan is approved by the humans, so they can also do the workflow generation. And for the plan, actually the agent can do a self-reflection, review the plan by themselves, and you can also invite the agent or other agent or humans to review the plan. And for workflow layer, the execution engine, both humans and the AI agent, they can review the final results from the workflow, or they can review the intermediate results from the workflow. So those kind of feedback from humans or from AI or agents, they can be stored in the memory of the agent. So as we said, we need to like support the evolution process or continuous learning process. So memory would be a very important component for this process. The agent can improve their capabilities or skills of using some tools, for example, during this learning process. And on the right side, we have listed some responsible AI plugins. So they can be applied to different layers or components. We will discuss the details on the later slide. And if you look at this slide, some boxes are with gray background. We call them also design patterns. They are like also reusable solutions for building the agent. And a similar idea like the responsible AI pattern catalog. We also recently released a agent design pattern catalog, summarizing the solutions for designing agent. And also we use the template to describe the design pattern for agent architecture. And this is also one of our recent work on agent. So I think because these days we are doing different like industry projects, and usually our clients ask us to evaluate their agent architecture, whether the agent can meet their intended goals or they can meet their governance requirements. So that's the motivation for us to propose a new architecture evaluation methods for the large language model agents. So this one is more like a diagram of showing the process of this method. Like the first step could be understanding the agent goals or review the governance needs. For example, there are like AI safety standards in Australia, maybe in other countries there are other standards. Depending on the location, you can decide which governance standards are relevant. Or organization, maybe you have your own AI policies, you could also integrate them into the requirements. Then we also need to, of course, review the architecture of the agent, like identify the architectural patterns, tactics, identify what kind of guardrails this agent has adopted. Then we have also developed a catalog of agent specific general scenario. I will show it on the next slide. So based on those general scenarios, we can define the context scenarios for the specific agent. For example, for accuracy, what could be the context scenarios? Then we will give different priority to these scenarios. And this process can be also done at runtime. So after analyzing the agent architecture, we do the recommendation for improving the architecture. So this is the process. And this is some examples for general scenarios. For example, for accuracy general scenario, the source could be user or context engine. So you can see here is different from traditional software architecture evaluation. I think for ATAM architecture method, the traditional one, they usually talk about the stakeholders as a source. But here, I think for agents, sometimes it's like the agent artifacts trigger the stimulus. So this is a good example for this case. So the context engine, they could suggest a goals. So then the context engine, they can become the source of the stimulus. Then the stimulus could be a goal achieving request. Then the artifact is the entire agent because it's relevant to all the components in the agent architecture to help achieve this goal. Then we have like the response measure. So we could have like developed this type of scenarios for the specific agents in the projects to support the evaluation process. And of course, we need to think about the quality attributes. And in our paper, we have listed, I think, more than 10 software qualities. And we selected those quality because we mapped them. I think we mapped the AI safety standards to the qualities. In this way, we identify like which qualities are important to support to enable the guardrails. And this is another work related to AI safety. So guardrails, I think these days are used very broadly. Sometimes you can see it's relevant or it's interchangeable to responsible AI or AI safety, but sometimes it's just focused on runtime guardrails. So in our work, guardrails means the runtime guardrail mechanisms embedded in the AI agent. So for example, you can think about ChatGPT. If some prompt with some private information, they are sent to ChatGPT. So they will have a layer, maybe do the modification to the prompt. So this can be one type of guardrails, like filter some information, block some information, block some prompt. So this taxonomy try to characterize the guardrail design. And we first analyze what could be the motivation. And actually, there are external quality attributes for building guardrails, like whether it's designed for improving accuracy or designed for ensuring fairness, safety, what kind of requirements for guardrails. And then the next one is quality attributes, but they are more like internal quality attributes compared to the first group. For example, we can have seen many papers talking about the results before using guardrails or after using guardrails. So they could be viewed as accuracy. But I think generalizability or customizability are also very important. Like some users, maybe they have their own requirements for guardrails. So they are also customizability is also very important quality attributes for designing guardrails. So here we list out all the important qualities, including customizability, adaptability, traceability, interoperability, or interpretability. Like you need to understand what kind of guardrails have been applied. Regarding the design, The action group is different types of actions for guardrails, like block the prompt or filter the prompt, flag some important or PI information to get people, human involved, or log in the whole process or isolate the AI component. They could be all viewed as guardrail actions. And for targets, and here we try to emphasize it's not just about the user prompt or output from the agent. It can be every artifacts generated at runtime, like the user goals or the context information detected or the plans generated by the agent, the tools selected by the agent. So they are all important. For example, the tools could have like vulnerability issues. So before the agent connect with the tool, you need to detect or analyze whether the tool has any vulnerability or quality issues. And regarding the scope, some guardrails, they could be relevant to the industry level policies, or it could be from the user's personal preference. So we also have like a different scope of the guardrails. Then for the guardrail rules, we can configure the priority of different rules. Some rules, maybe they have high priority, and some rules, they could be negotiable. We call them softer rules. And for modality, here, I think we try to say guardrails is not just for protecting the text input output. If the foundation model, they are like multimodal guardrails, they could also be used to protect the image input output or video input output. Some like if you think about the Gemini's demo, the UIs are generated at runtime on demand. So the UIs may include, for example, some unethical images or private information. So you need to have like a multimodal guardrails to help detect the dark patterns included in the UI or images generated by the model. So this is the taxonomy for guardrails. And now we are, in our team, we are building multi-layered guardrails. So inspired by the Swiss cheese model. So we want to have like a Swiss cheese model for AI safety. So this architecture is like a simplified architecture for agents. So on the left side, you see the context engine, the prompt optimization, reasoning planning, workflow execution within the agent part. But if you think about the example we just used, the prompt may have some PI information or may have some security concerns, like they try to get the company's business information, or they try to have some dangerous goals embedded in the prompt. So at the context engine or prompt optimization level, we could have the prompt modification or block guardrails. But for the reasoning planning stage, it's also very important. We could have verified to like externally to support this level of guardrails. For example, we could check whether the plan generated by the agent, they are compliant with policies or not. So in the business process community, there are, I think, a lot of work working on formal methods for specification of workflows. So if some workflows have been formally specified, we can reuse those workflows, or we can reuse the workflows stored in the organization's repository, so the agent do not need to generate the workflows. So in this way, we have also we have guardrails at this level, and we can do logging and log analysis to ensure the plan is executed accurately. So that can be also viewed as a type of guardrails. Then for the workflow execution, we could also have exception handling. There could be some issues about when the agent call the external tools, like takes longer time than expected. We could force the agent to complete this step or switch to another tool to call. So they could be viewed as exception handling mechanism. So different types of guardrails could be applied to this agent workflow. And this last slide, I think, is a screenshot about our agent platform. It's a no-code, low-code platform. So at the top, you see there's a window called Zapper Copilot. So the user, they can use natural language to communicate their requirements about the agent. So then the platform, they can create a personalized agent using this structure. We call it SPL language. So on the left side, you see we break down the requirements into different fields in the form. For example, we analyze the persona of the agent, we analyze the terminology used, the target audience or guardrails for this agent. Then we also visualize the workflows generated by the agent. So the users, they can provide feedback to the workflow. So they may prefer different orders, or they want to adjust make some changes to the workflow. Then we deploy the agent and execute the agent. I don't know if we have time to play a demo video here. Yeah, so I can.
Yes.
Yeah, I can maybe open a demo video we recorded recently about this platform, so you have some idea about this. Let me switch to.
Sapper enables people without any programming background knowledge. Sapper enables people without any programming background knowledge to build their own AI-powered program, which is also called AI agent. Such agent performs tasks or makes decisions on its own, using data and algorithms to simulate human-like intelligence. Here is the homepage of the Sapper. User can create and access their historical data in this panel. Now we create a new AI agent named Gene Annotation Agent here. We click the agent card to enter the agent development page. Users can design, test, and deploy their own AI agent here. Users can also upload their own knowledge base files to assist the agent creation process. On the right side, we have our Sapper Copilot panel to manage the user inputs and interactions. Users just directly input their needs in natural language, and all the codes, logic, and workflows will be generated at the back end automatically. Now let's assume a researcher, John, needs an AI agent to help with a gene annotation task. He talks to the Sapper Copilot and creates this agent in just a few sentences. After a short wait, several forms are generated showing the details of the AI agent, including the agent's features and a step-by-step task breakdown. By editing these forms, written in natural language, users can easily modify the details and logic of the AI agent without writing a single line of code. The generation process includes the persona of the AI agent, the target audience, and rules the AI agent should follow. Additionally, there are guardrails to prevent risks like data leakage and vulnerabilities. At the bottom, a workflow is generated, displaying the logic of the AI agent. We call this the AI chain. It breaks down a complex problem into many subtasks, automatically assigning tools to each one. The AI chain also analyzes task dependencies and ensures that data flows correctly from one subtask to another during execution. It generates suggested outputs for each subtask to assist in their execution. Each task panel also includes rules that must be followed to ensure high-quality results. Users can view and edit each item within these panels or communicate with the Sapper Copilot to make edits. Sapper can also provide automatic suggestions to enhance the AI chain and improve overall performance. On the Copilot panel, you'll find suggestion buttons. Simply click one, and the AI chain will update automatically based on those suggestions. At this point, We've demonstrated all the functionality needed for users to build a no-code AI agent. Now users can proceed to the next page to run the agent. Here, users can upload relevant knowledge base files on the top left, and they can also debug the agent using the console below. On the top right corner, the AI chain panel illustrates the agent's workflow as a graph, clearly showing the connections between subtasks. The agent begins execution when the user clicks the Start button. The current execution node in the AI chain is highlighted. If the agent requires additional information from the user during execution, it will pause and wait for input. After the user provides the required information, the agent will resume execution. During execution, logs are printed in the console panel in different colors. We can see guardrail messages in dark blue, reasoning in dark red, tool calling in orange, and self-evaluation in purple. After a task is executed, the agent self-evaluates the results by comparing them to the suggested output. If self-evaluation fails, the agent pauses and asks for user feedback. This feedback and the self-evaluation results are used by agent ops to improve the agent's performance. The execution results for each subtask are displayed in the chat panel. After all subtasks are complete, a final report is generated.
Yeah, I think that's all for the video. Yeah, that's actually that's all for my talk. Thank you, everyone.
Thank you very much, Dr. Liu. Now, do we have any questions from the listeners tonight?
Yeah, let me begin question because she has just touched so many things now. Dr. Lu, yeah, you mentioned, I saw supply chain there. I saw supply chain. So do we have this SAPA, intelligent agent? How does it work? Because we are actually doing something in fact, today we had a lecture with WTO on supply chain and AI. We are running a program with them, University of Bolton. And then we're trying to develop their own system that will be different, so that their data is not leaked out, because I also saw it, from this video, it said leaked out. Now, so first I want to know whether the supply chain you mentioned, we can adapt it to the AI and trade area. Number two, all those the data, how is the security? How is the security package? Because they don't want their data to be outside. So can we have this intelligent agent also built for them? Because if it works very well, I may have to bring you back, to them soon. Mm-hmm.
Yeah, sure. I think we mentioned supply chain, but with maybe work on supply chain on the other way. So we look at the AI supply chain. So AI supply chain, because we need to understand the models of some third-party libraries, whether they are secure or not. So I think there's a concept called software bill of materials. We have also a couple of papers on that. So we want to apply software bill of materials to AI supply chain. And I think regarding supply chain, if you want to use agent, yes, but depending on your purpose, whether you want to monitor supply chain or not. My experience, we used to use blockchain to build the infrastructure, to do the data sharing. Then some data maybe you need to store it on the blockchain. Some data you need to store it off blockchain. But you can use agent, of course, to do the analysis, and also maybe you have some external tools to support this analysis process. But I think yes, as I said, our angle is more from AI supply chain. So because we have some team members working on vulnerability detection, so we want to know two things. I think whether this organization has any AI application, or how many AI applications they have. So the board members, they need to report the number of AI applications. So we want to know the software applications, whether they have libraries, machine learning libraries in the application. So we have developed a tool called the AI discovery tool. From that tool, we can the output will be the number of AI applications. Then in this way, we can say risk assessment is not just relying on people's subjective view. We rely on technical tools to give the answer. So that's the purpose of AI discovery tool. Then once we know which AI applications they have in the organization, we have the vulnerability detection tool. We have designed a knowledge base. So that one is like checking whether the machine learning library has any vulnerability issues and what are the sources. So this could also help with the supply chain risk. And in our question bank, we also have some supply chain questions. But I think for software supply chain, depending on your purpose, there are different technology you can use. But based on my own experience, I think you can maybe also consider using blockchain to build this infrastructure, then using AI to do the analysis. That's my suggestion.
Yes, we brought in IBM also. You know, IBM built something 4 years ago and they had to abandon it because of the, too much cost that is there. So we're trying to develop something using the AI and the supply chain. It's a new area we're all developing.
Yeah.
So we'll bring you in the discussion later on because, we totally developed new thing, that we're all trying. And everybody is just putting heads together to see how it will work. And if it works, it's mighty, a whole lot of materials that is currently going. So I will add this video to the video of the WTO training and allow them go through it. Then we'll bring you back again later on. Thank you very much. Yes.
Thank you.
Other questions?
Do you have any other questions for Dr. Lu, please? Okay, well, if there aren't any other questions, I'll just hand over to Sam Johnson to present your award. Thank you.
Thank you.
Thank you.
Thanks, everyone.
Thank you. Thank you so much, Dr. Lu. I'm Sam Johnson, Head of the School of Arts and Creative Technologies at the university, and computer science sits within our department. I just want to say a huge thank you for your presentation this evening. I don't know about everybody else on the call. I thought that was absolutely brilliant. There's so much, you shared so much information and with such clarity and precision. So thank you so much, Dr. Lu. And I think it was wonderful for us to be able to hear about that cutting edge research that yourself and colleagues are undertaking in terms of the prevention of negative consequences of AI. That was really, it's amazing to be able to hear about the kind of work that you're undertaking with colleagues. So thank you so much, Dr. Lu. And I think either Lovely or Larry would probably be able to bring your electric award onto the screen. Does somebody have Dr. Lu's award ready?
Oh, yeah, just a moment. Oh, okay.
Oh,
Fantastic.
Thank you so much.
Thank you so much, Dr. Lu. That was such an informative session. And as I say, I mean, I'm sure Dr. Celestine and I would be delighted if you continue to do work with us and with our other collaborative partners. That was a wonderful talk. Thank you so much.
Thank you for the award. Can I do a screenshot?
Yeah, we'll send it to you. We send you a copy.
Thank you.
Okay,
Yeah.
could we congratulate Dr. Lu, please? I think that was a wonderful talk. Congratulations. And thank you to all of our students and guests this evening as well for continuing to support November to Remember. Another evening to remember indeed. Fantastic. Thank you so much, everybody. And I'll see you soon.
Thank you.
See you, everyone.
Thank you,
Thank
everyone.
you. Bye.
Thank you.
Good night, everybody.
Thank you. Thank you and good night. Thanks.